Tasty basic architect. Yeah, look at that view, huh? Absolutely beautiful. We're on the 15th floor of a multifamily project, basically apartment building. So let's talk about a few things that I've noticed here. Look at this. All of their walls here are framed with 2x8s and then a furring strip to pad it out and get it out in front of the concrete. So you can see there's the 2x8 and then there's basically a 2x2. And you can see when I go down here, the 2x2 rides past the plate. And that's to get that insulation and get some thermal break on the edge of this concrete curb here. And it's all that 2x8 wood framing. Now, they have a whole series of steel columns, you can see here, and they get wrapped in Rockwell. So intermittently at all of the corners, you'll see some down there, but look at this view from this top floor apartment here. Absolutely gorgeous. And it's all concrete frame with steel pipes. There's a steel pipe in the corner there, and then another one here to pick up those concrete planks. Also notice at the stairway or at the doorways here that the frame is about 2 inches higher than the floor. And the reason for that is they're going to get some insulation out there, but this is going to get somewhat like a gypcrete floor system, and it'll all be radiant floor heating here. Also, we have the fire suppression system there. But one of the things that is really cool that I haven't seen before but makes total sense is that. What is that? That is a bathroom pod. Yes, notice all of the water lines. Notice the sewer line, the back of a wall-mounted toilet. Now, we can't get in there because this one's locked, but we're going to get into another one. And notice it sits on that little trough, and then it has connections there for the shower and trap. But all of the water lines and electrical are here. And this thing is basically on a, say, containerized frame. Steel frame, it comes up, gets bolted there. And if we go around the corner here, you'll see the size of it. Now, I'm told inside it is already tiled and finished, so it's getting made somewhere else and then basically lifted into place. The door is there, and you can see they are very secure about it. You can see the electrical is already run, but not only do they have a lock on it, but they have tape there, so they know if somebody's been trying to get in there. Believe me, I've tried to get permission to get in there, but we didn't. But what a pretty cool technology. So we're here at 15 stories up, and they're just basically craning these bathrooms into place. There's another one that I saw here, and I'm assuming these concrete walls there and say here, these are just shear walls that are going up through the building for stiffness. But you can clearly see here, this is another one of those bathroom pods, and it has the plumbing, outlet there behind medicine cabinet. You can see there's a bunch of electrical conduit buried inside of that insulation, and then again the doorway there. So very cool technology in a sense that while you're building the building, somebody can be putting these bathroom pods together, and then they simply get delivered. Another thing I want to do is take a step outside here. You can see there's that step that I talked about there. I'll step out onto the roof. So we're out on a roof deck. There's another door there. You can see there's a little curb, and I'm assuming this is going to get some kind of railing and deck system because look at that view. Absolutely gorgeous view. You can see a bunch of islands there, and then this fortunate homeowner has got a house even higher than our elevation here. But you can see we are pretty high up down there. Like I said, 15 stories. But let's talk roof drainage. So we basically have this giant pan, and you can see they did a really good job. It's turned up the parapet, it's turned up the wall, the wig glove, the flashing at the corners. They have these pretty neat round disc-like corners there that they flash, and nothing is like built up on top of each other. It all stays in the same plane. And then, like I talked about earlier, this is all an exterior gyp, and it gets the Sega wig glove tape to air seal it all around. But let's get back to our talking about the decking here. So this is a giant shower pan, and you can see what they've done is they've actually created a little trough in the roof there, which is really interesting to me because I question, why would you do that? And you can see there is the roof drain, right? And so I'm just gonna get my shadow out of this, but that trough goes all the way there and goes all the way up. So this is basically sloping into the trough. That is sloping into the trough. The trough then slopes to the roof drain there. Now, one of the questions you might be asking is, what if that clogs and has a failure? Well, interestingly enough, if we go upstream, eventually, just above the height of the trough, we have a little scupper, that little pipe. And then that'll push water out over the face of the building and become a visual alarm to any of the water leaking. But the big problem that I have is, why are we building this trough in the first place, right? My understanding of water management is every time we turn a corner like that, or the lower corner, we put material in a very challenging position to manage water. And you can see there's a series of seams there, there's a series of seams there, a series of seams there, and then you have basically all of those seams there that become very challenging positions for the water. It's kind of like we're pushing all this water into a drain to carry it away, but then we're asking the drain to do more work than the roof is, and that drain is put in a very, very challenged position. As opposed to, if we were doing this in America, typically, this would just come to a center drain here. So that would slope to a center drain, this plane would slope, this plane would slope, and the plane that here would slope forward. The drain would be somewhere in the middle there, and you'd have basically 4 valleys of sloped insulation, and then the roof would get put on top of it. And the beauty of that system is all of the roofing membrane stays in the same plane. There's no change to a vertical plane like this trough. And in my eyes, that's far less challenging. The little scupper idea, I like it, but I gotta say, you know, in America, again, we'd have the drain, and then about 3 or 4 feet upstream, we would have a secondary drain that goes down. So if that accumulated a bunch of dirt and was failing, water would just simply back up about 3 feet. And in this case here, it might rise maybe a ½ inch, and then the water would drain. But you could effectively do that in the middle of the roof here too. So anyways, it's pretty interesting construction. We'll take a another shot here just because it is so beautiful. Norway is a beautiful country, and I'll tell you what, we are very fortunate today because it's probably about 60 degrees out and blue skies. So anyways, we'll take a last pick because I do think this is a pretty cool idea, right? The bathroom pod. How cool is that? All right, well, we'll go see what else we can find. Steve Basic Architect, you know it. Long live our buildings. All right, well, just as I finished up that video, yes, they came over, one of the construction managers, and he gave me the reason on why they do the trough. So picture this. Over here, they basically put the floor joist and it directly bears on this roof, and it goes across and then up the other side. So basically water doesn't have the ability to traverse in this direction. It can only flow in that direction. So they need the depression to pick up that water as each joist bay is dumping water into that trough. It collects it and brings it down to the drain. So we now know. I don't think I buy into that design just because I know what the answer is, but I thought I'd bring it to you. So now it's the end of the video. You know it. Long live our buildings.